Hello, my name is Amara, and this is the function that we're going to be working with. And we've been asked to determine its concavity and then also to use the second derivative test to determine extrema. So the first thing we're going to do is just to take the first derivative so that we can look for our critical points. So f prime x is going to equal negative. We're going to use the quotient rule. Okay, so we're going to take the derivative of our numerator, which is x squared. We're going to use the power rule to get 2x times the denominator, which is 3x minus 6, minus the numerator, which was x squared, times the derivative of the denominator, which we can use the constant rule and the power rule, and that'll leave us with 3, or 3 minus 0, which is 3. And that'll all be over the denominator squared. So 3x minus 6 squared. Okay. So this is where we're at. I'm going to simplify, then show you what I've got. Don't forget the negative sign. So 2x times 3x is 6x squared. 2x times minus 6 is minus 12x. Minus 3x squared times 3, which is 3x squared, over 3x minus 6 squared is going to equal 9x squared minus 36x plus 36. Yes. Okay. So this is what we have now. I'm going to do 6x squared minus 3x and simplify that further. So now we'll have negative 3x squared minus 12x over the same denominator, 9x squared minus 36x plus 36. Okay, so now what I'm going to do is I'm going to factor so that we can cancel things out. So I'm going to factor from the numerator 3x. So 3x times x minus 4 in the numerator. In the denominator, I'm going to factor out, I'm going to factor out 3. Can I do a bigger one? No. Okay, I'm going to do 3. So that's 3x squared minus 12x plus 12. Okay, so now we have a 3 on the top and the bottom, so we can cancel that out. And then I'm also going to factor the numerator further because it can be the denominator, because it can be factored further. So in the numerator, we're going to have x times x minus 4. In the denominator, I'm going to factor out 3 again. So it'll be 3 times x squared minus 4x plus 12. Plus 4. My bad. So that's where we're at. And then I can actually factor what's in the parentheses again. A lot of factoring. So in the denominator, we'll end up having x minus 2 squared. 3 times x minus 2 squared in the denominator. And then we still have x times x minus 4 in the numerator. And then that's as much as I can factor it. So that is going to be our first derivative. Okay, that is our first derivative. So now we can use that to get our critical points. So a critical point is anywhere, because this is a critical point is where our function will equal 0 or where it'll be undefined, and this is a fraction, so it'll only be undefined when the denominator equals 0, and it'll equal 0 when the numerator equals 0. I hope that was understandable. Let me say it again. The fraction will only equal 0 when our numerator is equal to 0, and it'll be undefined when our denominator is equal to 0. So I'm going to first I'm going to set the numerator equal to 0. So we have x and we have x minus 4. So I'm going to set x as equal to 0, and that's just x equals 0. Then I'm going to set x minus 4 equal to 0, and that's just going to equal x. You're going to add 4 to each side, and that'll equal x equals 4. X equals 4. Okay, so we have two critical points so far. Now, if you look at the denominator, it's the x minus 2 squared that has to equal 0. So we're going to set that to 0 to equal 0. We're going to take the square root of both sides. Square root of 0 is 0. So x minus 2 equals 0. Then we're going to add 2 to each side. So we have x equals 2. So we've gotten 3 critical points. 0, 2, and 4. So let me write that down. Okay, so I'm going to set up our table for the second derivative test. So we have our x values. We're going to have those be 0, 2, and 4. And then we're going to, give me a sec here. I remember what we got to do. We're going to find f double prime. We're going to find the second derivative so we can test these points at the second derivative function. And then we're going to see what our results are. Okay. All right. So this is what my table looks like. So before we can test these at the f double prime of x, we have to find f double prime of x. We have to find the second derivative. So I'm going to rewrite the first derivative down here. And I'm going to just rewrite x times x minus 4 as x squared minus 4x. And then I'm going to keep the denominator the same. X minus 2 squared. Okay, so don't forget the negative. So we're going to do the quotient rule again. So f double prime x equals negative. Okay, so we're going to take the derivative of the numerator. We're going to use the power rule. We'll get 2x minus 4. Okay, times the denominator. So that was 3 times x minus 2 squared, subtracted by the numerator, which was x squared minus 4x, multiplied by the derivative of the denominator, which we're going to actually use the chain rule on this technically. So if we use the chain rule, we'll get 6 times x minus 2 times 1, because the derivative of the inner part of that is going to equal to 1. So now, oh, and then the denominator is going to be 3x minus 2 squared. Then we're going to have to square all of that. Okay, so this is how we've set up our second derivative. We are going to simplify things now. So let me do that. So 2x times 3 is 6x. 2x, or minus 4 times 3 is minus 12 times x minus 2 squared. Minus 6x squared minus 24x times x minus 2 over 3, oh wait, no, squaring it, so it'll be 9 times x minus 2 to the 4th. Okay, so we can factor out the x minus 2, so let me do that. So cancel this. and this will become a 3. So now we have 6x minus 12 times x minus 2 minus 6x squared minus 24x over 9 times x minus 2 cubed. Okay, I'm going to simplify again. So we're going to multiply things together. 6x times x is 6x squared. 6x times minus 2 is minus 12x. Minus 12 times x is minus 12x. And minus 12 times minus 2 is plus 24. Minus 6x squared plus 24x. All over our denominator was 9 times x minus 2 cubed. Okay, so this is what we have, and we can actually cancel out a lot of this. So we can cancel out the 6x squared and the minus 6x squared, the 24x, and then the 2 minus 12x's. Okay, so now we'll have 24 by itself on the top, and then 9x minus 2 cubed. And we can't really do any more with that, so that is going to be f double prime. That's going to be our second derivative. So now we can do our second derivative test. This is our second derivative. Okay. So let's input 0. If we input 0 here, we have minus, whoops, I'm gonna use a calculator. Minus 24 divided by 9 times, well, 0 minus 2 is minus 2. Minus 2 cubed. Okay. 0.3. You know, I think I'm just going to use by hand because I don't think I want to. Actually, it doesn't matter. It doesn't matter if it's a decimal or a fraction. It gives us a positive number, and that is what matters. We get a positive number here. It's technically 0.33. Repeating. Okay, let's input the 2. So minus 24 divided by 9 times, I said 2, right? So 2 minus 2 is 0. Ooh. Uh-oh. That's kind of weird because it's undefined at that point. It's undefined at that point. Okay. All right. Okay. Let's do 4. 4 minus 2 is 2. 2 cubed is 8. Okay. So minus 24 divided by 9 times 8. It's a negative number. So that's negative 0.33. Okay. All right. So, that's what I've got in our table so far. So for 0, we had a positive number, which means that it's concave up. And if it's concave up, then that means it's a local minimum at 0. Okay, let's look at 2. 2 was undefined. So I think that means we can't determine if that's an extrema using this test. Yes. So yeah, we don't know. We don't know what's happening there based off the second derivative test. Let's move on to 4. it was negative. So it's concave down, which means there's a local max at 4, at x equals 4. Okay, I really hope that's correct. 2 minus 2, yeah, that's 0. But yeah, it was undefined at 2. So this is what the table's looking like. So now we're gonna rewrite that as like a sentence. So we say that there's a local minimum at 0, f of 0, and then there's a local maximum at 4, f of 4. And that can be our final answer. Okay,